Tasnádi Zsolt. He will present Uncle about meets Drupal.
Hi everyone. I will present today Uncle Bob meets Drupal. I'm Tasnádi Zsolt. I'm technical lead at Fighter Plus. My IRC is KPT, my IRC nickname. Also I'm active on Twitter with the Z-Tasnádi username. And I'm doing Drupal since 7 years. Last year I was at Szeged at the Drupal developer days, and I tried to help on rewriting the session.inc to be object-oriented for Drupal 8. And I had a really big problem with that, because we had just one class, and in that class we managed the authentication, we managed the storage for the sessions, and it was really hard to rewrite that existing code to have something reusable, to have something which can be extended with new storage engine and so on. Just after the Drupal developer space, I started to work on Ruby on Rails on a new project, and I read a couple of books from Sandy Metz, and I recommend you to search and to try to read her books, because she is presenting a lot of principles how to write good object-oriented code. And I know that several Drupal developers, they are not used to work with object-oriented code. We had some object-oriented code in the C+ module, we had some object-oriented code in the views module, but Drupal 8 is something else. You can have now all of the just classes in the modules, and it will help a lot in the future if we try to keep some of the principles. And let's meet Uncle Bob. Actually, his name Bob Cecil Martin. It's a Ruby developer. He wrote five principles, and he says that if we are trying to apply those principles in an object-oriented code, we will get more manageable, more understandable, and more reusable object-oriented code. Let's see what solid means, because all of this presentation is about solid. Solid is an acronym for 5 principles: the single responsibility principle, the open-close principle, the least code substitution principle, the interface segregation principle, and dependency inversion principle. It's a little bit hard to follow this. I will try to present each principle on one slide very quickly, and after that we will go to see an example. Single responsibility principle. It means that every class, every function, every module should have only one responsibility. Open-close principle. It means that all of the classes, all of the modules, all of the functions should be open for extension but closed for modification. These images will help a lot to understand each principle, and we will see also by example what they mean. Least code substitution principle. I think it's the hardest to understand, but it's a simple principle. It means that each subclass should be substitutable for the classes from which they were derived. Interface segregation principle, it means that each client should not be forced to depend on methods they are not using. You see this on. And on dependency inversion principle, you know this like dependency injection in Drupal 8 and Symfony. It means that high-level modules shouldn't depend on low-level modules, and they both should depend on shared abstractions. What? We'll help Mr. Bean to understand the solid by an easy example. To be able to understand these solid principles, we'll have a problem, and the problem sounds like this. NSA are sending some classified messages to CIA via an RSS feed. The messages are encrypted, and we should get the messages, we should decrypt them, and we should save them in the database. NSA is using the Caesar cipher. I'm pretty sure that everyone knows what Caesar cipher means. And we need also to save the messages. We have Drupal 8. In Drupal 8 we have the key value storage. I choose this storage because it's easy to use, and you will see in the example how I'm using it. For each message we will store a key value pair. The key will be the time when we got the message, and the value will be the message itself. Okay, the first try, when the developer comes from Drupal 8 and doesn't know a lot of object-oriented programming, he tries to do everything in one class. We have the RSS messages parser, we have a public function execute, and we are trying to do the job. This means that we have a key value store where we are storing the data, we are fetching the messages in another function, and after that in the for each we are decrypting each message and saving in the key value store. It is okay? Fetching the messages is easy. We have a protected function in the same class where an RSS parser is getting the messages from that URL and is returning the items. Decrypting the messages is also simple. We are defining a range, we are splitting the encrypted message, and after that we replace the characters with the ones we need. Looks nice, it is working, but if someone with experience sees it, he will say that there are a lot of issues there. What is wrong with this? What if the URL will change and we need to get the messages from somewhere else? What if the encryption time will change and we could use other encryption algorithms? What if we want to read the messages from someone else, from an online newspaper, because NSA wants to send like this, or we want to read the messages from a file? And what if we want to change the storage engine and to put in MongoDB or any other storage engine? Let's try to rewrite this solution. If we check the solid principles, the first one is the single responsibility principle. Single responsibility principle is applied when a developer, Dorel or Dorel, will be able to explain what a function is doing in one sentence single responsibility principle is not applied here. What we are doing now is that we'll split our class in multiple classes. This means that you will have the old RSS messages parser to do the execution, but we introduce the NSA cipher and the RSS messages class. Each of those classes will have only one single responsibility. The first one will retrieve the message, and the second one will fetch the message. The NSA cipher will look like this. The RSS messages class is also one class with one function. It's more easy to understand also the code because they are separated in files. And we are going also in the methods, and we try to split them. We introduce a new protected function for parsing, where it's, we are handling only one message there. What would be the next step? Because the feed URL can change in time, and we had it hard-coded. Also, the step used in the NSA cipher could change. And for this, the open-close principle, if we apply it on the code, will help us to solve these issues. This means that in NSA cipher, we could introduce this step. And like this, NSA cipher will open for extensions, but it's closed for modifications. Actually, we need to do other two steps, but I will return when we are speaking about the dependency injection. And also, if we are introducing this step, NSA cipher will be a generic class. We can rename it, and we could rename it as Caesar cipher, and we will get a reusable class. Also, the RSS parser will do the same with this class. The URL now is coming from the constructor. And when we are using the RSS parser, we are sending the URL in the constructor, and our class will be closed for modification. Okay, but we are using Drupal 8. What this means? That we have the container injection interface, and we could get the URL from the state. Yesterday, Öcsi had a really nice presentation about Drupal configuration. State is something similar to the configuration. The only thing which differs that in state we are saving the site title, and it's a configuration which can be modified by the user. Okay. Let's see the dependency immersion principle. Drupal 8. You probably know that Drupal 8 introduced services, and we can use dependency injection. This means that in our Drupal module, we could have a file named module name.services So we are defining two other services, the zipper here and the fetcher. This will allow us to change the fetcher class if we need it, because the services are loaded by default by the Drupal core, and we can change the services are loaded from other modules. Using those services, our RSS messages parser class is changing, because our constructor will get an object for each service, and this key value factory, this fetcher, and this zipper will be loaded automatically by the dependency injection container, and our fetcher could be an RSS parser, could be a class which is reading from a Google document, it could be API or anything else. And this means that if we are changing the fetcher, we will not need to change our code from the RSS messages parser, because we have the fetcher interface defined, and if we write the new fetcher to implement this interface, our job is done. And the result is self-explanatory. With this code, we will be able to change the storage. We can use MySQL, we can use MongoDB, we can use any other storage engine. We can get the messages from different providers. We could use other encryption algorithms. And also, I know that you don't like to write tests, because any developer don't like to write tests. But writing unit tests for these classes, it will be piece of cake. Because I tried several times to contribute to Drupal 8, and I had a really big problem, because at least last year we had a lot of classes which didn't implement the single responsibility principle. This means that writing unit tests from those classes, it was really hard, because each method did 5, 10, or 15 different things, and writing unit tests for one method, it took around 1 hour and several lines of code. Okay, I said that Solid has 5 principles. I presented you 3 of them. We didn't apply on the code before the list code substitution principle and the interface segregation. Why? Because we didn't need it. It's a simple answer. And if you will read some of the books from Sandy Metz, you will see that she is trying to say to us that we shouldn't abuse of these principles. If you have a single task and you will know that that class will not be modified and your specification will not be modified in the lifetime of the project, you should write it. You should write the code as you want. But if you know that, for example, you are doing a project for a startup and the specification will change in the future, or you are doing an API and you want to have a reusable code, then you should apply these principles. You should apply the most principles you could. Let's see the list code substitution principle. Dorela is a student at Academy Plus. Academy Plus is a private academy where the students are getting she had to write a class for rectangle. It's easy. A rectangle has a width, it has a height, and this class is calculating also the area of the rectangle. Next week, at the academy, she had to write the same class for a square. And she asked herself, is a square a specific rectangle? She said yes. What she did? Class square extends rectangle, and public function set height is setting the width and the height. Public function set width is setting the width and the height. And everything is okay. The area will be calculated from the rectangle. But this will violate the least-code substitution principle. Why? Because what Dorella didn't know, that at Academy Plus we have some tests and her code is verified. A possible client to verify her code would be like this. The client is getting a rectangle, is setting the width, is setting the height, and is checking if the area is correct. But you can't send a square there, and this is an issue. Because what least-code substitution principle is saying, that if a class it is extending another class, you should be able to put that class in every place where the original class was used. Why is this wrong? It violates the LSP. I could live with that. But it demonstrates that when you are writing object-oriented code, you should stop mapping real-life objects to objects in development. Each object should be an exception for a concept and not an object in a real life. If we will try to map one-to-one real objects to programmed objects, we will almost always fail. After all, what the hell is LSP? And I checked Wikipedia for a definition, and it throws this. I don't understand this. Who understands this? Let's translate it in English. Child classes should never break the parent class type definitions, or subtypes must be substitutable for their base types. Let's see the interface aggregation principle. We'll choose another example from the Academy Plus. Dorel is in the second year at Academy Plus and he needs to write an RPG game. The game is based on interaction between creatures. He has two creatures. He has each creature in the game can talk and can walk. He creates an interface creature and he will have two functions, walk and talk. This is okay because he has two creatures. He has the human creature, which is implementing the creature, and he has the Martian, which is also implementing the creature. But in version 2, he will have a new creature type, dogs. And dogs can walk, and dogs can bark. You will say that some of the dogs from movies, they can talk, but in this game, they can't. This means we can't use the creature interface. But Dorel's solution is this. He is adding a new function in the creature, like bark, And now we'll implement the same interface because he wants to reuse the code for the work method. But this breaks the interface segregation principle. Which means that no client should be forced to depend on methods it does not use. A good example of this would be the node module from Drupal 8, because we have a lot of classes there which have methods and they are not used by other clients. What would be the correct solution? It's simple. We split the interface in 3 other interfaces. We will have the worker interface, which is defining only the work function. You have the talker interface, which is defining the talk function. We will have the marker interface, which is defining the bar action. And each class will implement the interfaces needed. Human will implement the worker and the talker. The dog will implement the worker and the barker. What we did here, we just applied single responsibility principle to interfaces. And if I want to explain easily what interface segregation means, it means that we have SRP in interfaces. Conclusions. I will repeat myself here because it's really important what I want to say today. That applying these solid principles means that our code will be really easy to understand because of SRP. It will take less than 5 minutes to write unit tests for each class. The code will be reusable, and we will be prepared for any change which will come. Last year, we lost, I think, 8 or 9 months of work in Drupal 8 because each class for nodes injected, for example, the MySQL database storage without any interfaces and without using the dependency injection. And when the core contributors realized that we might want to use other storage engines, we created 10, 50 different tasks on Drupal 8 and the Drupal.org to modify the code. Because working on the MongoDB module for Drupal 8, it wasn't possible to use a different storage engine because the MySQL database container was injected directly in the... It was specified directly in the code. And the most important conclusion, that writing code which applies these principles will make your technical lead happy. Thank you very much. Any questions? Yes?
Have you tried using this principle on Drupal 7 installations?
I have a short answer for this. Just open the views module, and knowing these principles, you will just get mad, and really mad. And the issue is that even in Drupal 8, the views module is not applying these principles. And I was in Drupalcamp Amsterdam last year, and I tried to help fixing a really critical issue on the views module, which was growing the cache exponentially. And we couldn't fix this because the code wasn't okay. It wasn't ready for extension. And when I worked in Drupal 7 and I made object-oriented code, I used this. I didn't know about these principles, but I think I used 2 of them. Not all of them, but 2 of them I used. Because I like to have all of my functions short